Record. Okay. Is it recording? Yes. Okay, welcome back again to Monday of week 2. I wanted to show you a secret thing. Now that you've had a weekend to practice doing some of the fraction homework that we did, fraction topics last week, then I want to show you a secret calculator key. So let's look at this one. We're wanting to reduce a fraction. We can do it by hand, and there will be some assignment that I'm going to ask you to do certain things without a calculator. If you wanted to reduce this without a calculator, you could. Maybe you saw 8 goes into both of them. Maybe you didn't and did it first with divided by 4 and then divided by 2. But this should look familiar after what we did last term. Your calculator has a key that looks like A, B over C. So look at your calculator, find that key. I don't think my fancy calculator has that one.
We use our phone calculators.
You can, except for the final. LCC, we will know phones on finals.
Yeah.
So don't wait till the final to switch over. Sometime in week 9 or 10, get a calculator, borrow one, learn how it works. Do you see an A, B over C key on your calculator? I'll wander around. So, phone calculators often don't have it. One, no, you have a funny Casio. So. No, that one doesn't. Okay. You do. Let me hold up yours. So if you have this Texas Instrument one, the one that's sort of the recommended one for the class, then there's an A, B over C key right there. So, thank you. If you put in a fraction, this key says wherever you see a fraction bar, press this key. So I can take the calculator and go 16, A over B, A, B over C key, and then 120, pressing this where the fraction bar is. And then if I do equals, what happens? It says just 2/15. So it'll reduce fractions for you automatically. Just type them in and hit equal. Then more than that, while you're looking at the 2/15, hit the AB over C key again.
Yeah.
And
Nothing happened after that.
oh, it should. Okay, clear. So if we put in the 16, 120, and it equals, then I do it. No, yours doesn't do it. Okay. It's on most of them that have it. It'll then switch it to a decimal. So you can keep tapping this key, and it will switch it back and forth between fractions and decimals for you.
How would you punch it in again?
How would you punch it in?
Yeah, like just
So yeah, 16. And then where's your? Oh, we do, yeah, 16 tap, and then 120, and then equals,
okay.
and then press it again. Yeah. Anyone else want help calculator wrangling? Yeah. Oh, okay. No, you're at that. Yeah, sure. Use the.
I use my
Yeah, TIs don't work the same. Okay. Anyway, I'm not an expert with all the different brands of calculators, but the people at the MRC desk have much more experience with that. So if your calculator doesn't have a good trick to do this easy, it might. I just don't know it. Check at the MRC.
So the one that you write on the syllabus to get, does it do that function?
It'll do this correct.
Okay.
You don't need it. It's just sort of a good way to check your work at the end.
Okay.
You're not sure. Okay, that was kind of an announcement, kind of a thing. The other thing I wanted to talk about was note-taking. Now that it's week 2, I'm assuming that people who want to register are actually here. No one's going to drift in. We can talk about really important things like note-taking. So how note-taking works kind of philosophically is that at the end of lecture, you're in trouble. You have whatever lecture notes the instructor gave you. For me, it's a website. Often it's handouts and things like that. You have textbook pages that go with that topic. You have whatever you wrote, and then you have a bunch of stuff in your head that you didn't have time to write. It might be things like, I like my old Math 10 way of doing this better. It might be something like this, I need to practice a lot, or this one I already know. And you don't want to have 4 different sources of stuff, because then when it's time for a test, you can't cram. You have too many piles of things to go look at. So your job when taking math notes is to sort of complete your notes. That's not an official word, it's just my slang. You want to take those 4 sources and squish them all together. Take what you started writing during class, go back onto whatever the instructor gave you, and say, I didn't write this in my notes, but I like that, so I'll do it. And then you want to go in the textbook and say, I really like this example problem, so I'm going to put it in my notes. That one helps me. I don't want to have to hunt for it when it's time to study for a test. Or maybe some other explanation of something. And then at the end, anything that was sort of floating around in your brain that was useful, make sure that finally gets written down. Then you'll have just one source to study from. Realistically, will you get completed notes for every math topic? No. Right? You're not an ivory tower student with no jobs or kids. This is your only thing you do all day. You have responsibilities. You're not probably going to have time to make perfect notes for every topic. But for the few topics that are your nemesis, right? They are your arch enemy if you were a superhero. Make sure for those that you go and make the best notes you can. Have all 4 things come together. Okay, what might good notes look like? I don't care. No one's going to grade you on your notes having a certain style to them. But let's look at some examples. I would not be a good instructor if I didn't give you some ideas. So these are things that work for lots of people, and maybe they work for you. Whatever you do, you want to make sure that your topics are clearly labeled. If we're switching from fractions to percents, you want that to be easy to see. The narrative, your explanations of how things work, and the examples you give, the example problems, don't blend together. That makes it too hard to read. When you have a definition, those are easy to find, and things are neat and easy to read. And if those are true for what you do during class, then when you add a little more to it after class, it will still be true. So here's one idea. Some people like 2 columns. They're not actually with a line down the middle. This column here would be much thinner and smaller off on the side on a real student's page. But on one side, you sort of write the traditional notes, titles, narrative, example problems. And then on the other side, you save just a little bit of margin for your ideas and comments, something that you stole from the textbook because you like that example problem better, things like that. Other students like a 3-column method. With this method, you take your description of how things work and put the narrative on one column and the example problem that goes with it in the middle. The advantage of that one is that when you don't have an example problem, it's blindingly obvious because there's a hole there in your notes. So you know that one of your tasks is to go and find your favorite example problem for that and put it in. And similarly, if you only have an example problem, then maybe you want to figure out how to write in a sentence what you're doing here. Because if you can't put it into words, then that's a danger sign. I've included also just a few examples from students from the past. Notice none of these look exactly like what I just showed you. But those are all great ones if you want some ideas, things to look at. Okay, questions about note-taking? No, okay, so if we go back here, you'll see that depending on what kind of grade you want, you'll have to show me some nice notes for different topics. So I don't care if it is a lengthy thing. It could just be a page or two, but you'll have to at least show me you can do this so that if you're moving on to Math 60, whoever your future math instructors are will know that, yeah, you're up for this. You can take notes if you need to. Okay, last announcement. There was a mistake I made and someone caught me. I am glad he did, but not in time for actually fixing it on the video. So this was 33.3333 instead of 3 before. I sent out an email correction about this. It's fixed on the PDF file, but in your notes, make sure that those aren't 33s anymore from last time. Okay, question?
So what was wrong with this question?
That when I did it before in class on Friday, it was 33 instead of 3. So don't make it be a 33. Okay, sorry for my coughing today. My wife has had a cold since the middle of December and I finally caught it this weekend. I was doing so good. Okay, anyone need this up more? We're good. Okay, then I'll get rid of that. More fractions homework questions before we start a new thing. Questions for fractions homework. Textbook homework, turn-in problems. Yes. Number 7 in the turn-in set?
Yeah.
Okay, let's go look and see what that one is. Decimal form for 4/20ths, that one? Oh, okay. Okay, 2 ways to do this. If you are annoyingly clever, you'll notice I can change 20 into 100. How do I do that? Now that would be 10. Fine. I can do divided by 2 too. That'll work on this one actually. So 20 100ths is just 20 100ths. So there we go. I could have made it 2/10 with divided by 2 top and bottom. That's not how most people will do this. Because again, you have to notice something clever about the denominator. So the way that most people would do this is just say a fraction is like a division problem waiting to happen. 4 divided by 20 is going to be 0.2 and we're done. If you don't want to get out your calculator, then we could say how many times does 20 go into 4? It doesn't, so we need a decimal point. And then 20 into 40 is 2. So there we go. So again, the normal method is just to treat the fraction like a division, top divided by bottom. You have to write that on the board. A few of them, you might be able to do it without having to do long division if you don't have a calculator, but it's often not in the best.
Mine's going back a little bit. I couldn't find, okay, like to find the multiples. what were that little chart you have, like, so like to figure out if that number, like the 2 and 3.
The factors?
Yeah.
Yeah.
Is that on the note somewhere showing?
Yes, let me show you that one.
Okay, I just couldn't find that one.
So if you go to topics and shape shifting and divisibility and factors.
Oh, I was looking.
And then right there are the divisibilities. So, and now they're on the board. So
Move the factors of the.
actually, that's not fitting in one page. Let me delete that, shrink it. Okay, and now I can put it in the PDF for today. Okay,
Just
yes.
to clarify that, fraction homework is due on Friday, right? This
No,
Friday?
no, because
No,
we
the
had
rounding.
we had questions on it. Rounding is due on Friday. Fractions, we don't have a due date yet because we still have questions on. So. Homework seems to be due late because first of all, it's just for achievement stars for getting a plus if it's on time. You should be doing it to not fall behind in class anyway. And also not everyone has computers at home and it's hard to turn things in when you are using a computer code. So just for that reason. Yeah.
So when it says how many factors, when you find the factors, you just say whatever, you can go into that number. And then the prime factorization is when you do that little tree thing.
Yes.
And then you circle the numbers and then you like, say like 2 dot, 2 dot.
Yes.
Okay.
You got it.
Sure that I got that.
And to find all the factors, we sort of made a horseshoe shape.
I was kind of confused on that when I looked back at that.
Okay, let's do another one like that.
Oh,
So let's say,
that's good. I don't want that.
okay, if we make a factor tree, we're not going to get all the factors because if maybe your tree started with 8 and 10, then 20 isn't going to be anywhere on that tree. Right? So factor tree is a great, if you're looking for the prime factorization, that's the right tool. But if you're looking for all the factors, it's the wrong tool. So to find all the factors, we're going to start just counting. And on the other side, we're putting, if this is a factor, what goes with it. So 1 times 80, 2 times 40. Does 3 work? No. Does 4 work?
Yes.
Sure. 4 times 20. Does 5 work?
No.
Yeah, it ends in 0.
Yeah.
What's it going to be? Okay, does 6 work? No, because 2 and 3 didn't both work. 7? No. 8? Sure, 8 and 10. 9? No, and now we're back to where we were. So if anything bigger than 10 was a factor, it would need a little
Okay,
guy
now that makes
to match up with. So we're done. There's not going to be
Okay.
anything hidden.
That's what I. Thank you.
You're welcome.
Now that makes
Okay, let's go on to new stuff. So, we ended on Friday with decimal scoots. Remember our brave volunteer walking forward and
Yeah, yeah,
backwards and so on, right? So there were decimal scoots that were kind of making numbers bigger, decimal scoots making numbers smaller. So I won't go over all of that again. Look at it if you weren't here on Friday. The main thing we want to know, though, is about percents, which is like a special case of that. So first, what is a percent? You probably know. You've seen percents before. So we could rate things on a scale of like 1 to 5 or 1 to 10 or 1 to 100. How much do people like jogging or banana runs or elevator music? There is not really an English word for the scale of 1 to 5, although auto club ratings tend to make people think that 5 is the best if you say stars. So stars is like out of 5. If I say I went to a 4-star hotel, you're probably not going to think 4 out of 100. What a dump. Why did he do that? Right? For 1 to 10, there really isn't a name. For 1 to 100, it used to be cent. The cent means 100, like 100 pennies in a dollar. So per cent meant out of 100. And in math, we have 4 ways to do out of 100. So if I wanted to write like 47%, I could do that in 4 different ways. I could say 47 divided by 100. I could say 47 and do 2 decimal point scoots. I could say 47 over 100. Or I could say 47 times 1 over 100. So put this somewhere very clear in your notes. We're going to keep looking back at this today. We're going to look at lots of things to do with percents. And sometimes one of these is the best way to go about it. And other times another of these will be the best way to go about it. So this is like our secret decoder ring for how to deal with percents. Okay. Anyone need more time copying this? Okay, moving on. Okay, so here's in the typed out notes what we just wrote in our own notes. One thing we want to do is think about percents a little more clearly. And let's use a grid for that. If I wanted to shade 47%, how would I shade that on my grid here? Yeah, I'd say I'm going to color, there's 10, 20, 30, 40, and then 7 of them. So again, don't grade me by my artwork. Everyone happy with that? Okay, if I wanted to shade instead 4.7, what would I do? I'd shade 4 blocks. Yeah. How would I say the 0.7 formally? 7/10. So I want 7/10 of the next block, right? So a little more than a half. Again, don't trust my artwork, but then lastly, if I wanted to shade 0.47%, how would I do that? Yeah, almost half of a block. Half a block would be 50%, so a little bit less. Again, don't trust my actual artwork, you know what I'm trying to do. So having percents with decimal points in them is okay. Often we'll go from a percent to a decimal, but if the end result has some decimal in it, that's still okay. This is what it means. You could do the same thing with a big circle. If I wanted 70% of the circle, then what would I do?
Say 70%.
Yeah, so that would be half of it, right? That's 50. So 55, 60, and then more. Oh, come on. Oops, that's not going to the middle. So it would be like that much, right? Whereas if I wanted to only shade 7%, then I would just pick 7 tick marks. Or if I wanted to shade 0.7%, then I would do less than 1 tick mark, right? So I'd say not that one, but that kind of thing. So again, decimals in percents are okay. That doesn't mean we're doing something wrong. Questions about that? Okay. One thing that happens in real life, but not a Math 20 class, is you add up lots of percents and then say 100 minus that is what. So how much is the orange juice one? You'd have to add up all the rest and then subtract it from 100. We don't care about that. That's just adding and subtracting. That's not as interesting. Okay, so we have the 4 things. Your secret decoder ring we all carefully copied. The first thing we want to do is have a percent become a decimal. Maybe even make it a little bigger. Okay. So which of those 4 things will be the easiest one to do? If I want to take 47.1% and then take away that blue percent sign and put something else in its place, what should I pick? Which of my 4 options? Sure, I'm trying to go from percent format to decimal format. I want to replace the blue percent with one of the 4 things we just listed. So what's the easiest thing to do instead?
Move the decimal.
I could do it, make it divide by 100, but that's not the easiest one. Okay,
Move the decimal.
move the decimal. Yeah, one of the options was 2 decimal point scoots. And that's really easy, so that's going to be the easiest one.
That's what I'm wondering. Why the numbers?
Oh, because I'm sloppy. Because I'm thinking about what I'm going to say and not what I'm doing right now.
Just making sure.
Sorry. Okay.
So then that would make it.
So 0.471. Yeah, we're doing this one. Yes.
What determines how many times you
Yeah.
It's always 2 because back on this page, no, this is going to take forever. Back on this page, one of the things to make out of 100 is 2 points, 2 scoots to the left. Since percent is always about 100,
It's always gonna be.
then it's always going to be 2 scoots because 100 is 2 scoots. Okay, let's do more of these. If I want to write 3% as a decimal, then I'm going to take this blue percent and do something else with it. It's always going to be true that 2 scoots to the left is the easiest one to do. How do I scoot left with just a 3? Yeah, we're going to have to put a 0 there to fill in the spot. Do you have to write as much as I do? No, I'm lecturing, right? Okay, 30%. %. What's going to happen now? Where's my decimal point going to land?
1.2.
Yes. Everyone happy with all 4 of these? You can scoot. It's easy to do. You can do it at homework tonight. So again, the task is to take the percent sign and say, I want to get rid of it, have only a decimal. I can't just get rid of it because that would change the number, right? 3 is different than 0.03. So if I get rid of it, I have to replace it with something that means the same thing. That's fair. And 2 decimal point scoots to the left means the same thing. So there we go. Any questions about that? We'll be doing it a lot, so if you have questions, ask. Okay, guess what comes next? We just did from percent to decimal, so now we're going to go the other way. Now I have 0.75. I want to just slap a percent sign on the end and put it in percent format, but I can't. That would change the numbers. Question? For this one, no, fractions will slow us down. We could do it that way, but it's not the fastest. So I want to do something that's the opposite of percent. So I can slap a percent on and do the opposite. They cancel each other out and we're good. So we just saw that a quick thing was 2 scoots to the left. So the opposite of that is going to be 2 scoots to the right. So 0.75 is 75%. Try these for yourself. I'll do them in just a moment. Check with your neighbor if you're. So again, for all of them, I want to just put on a percent. I can't just do that though, that changes the number. So I have to do the opposite also to kind of undo that and get back where I started. And so the opposite is 2 to the right. Oops. The 0.666 forever still goes on, even after we scoop things. So don't round it to 66 unless it tells you to 67.
I have a hard time, like, that's easy one to do it, and I got it, but like, my brain wants to tell me that I'm not doing it right, like, there's more to it.
Yeah, no, that's it. Okay, that's it. Okay, so think again about that secret coder ring thing. Percent can mean 4 different things in math. if we want to take away a percent, we have to replace it with one of the things it means. So that it's sort of still there, even though we got rid of the percent symbol. So in this case, we wanted to get rid of percent, so we replaced it with something else that's the same thing, and that was 2 scoops of thought. Going the other direction, I want to put on a percent. I can't just put a percent after a number, that will change it. So I have to do what's the opposite of percent, and then we're all fair and square. Okay, we will do this so much this term that there's an acronym. So the acronym RIPLOP stands for right into percent, left out of percent. It doesn't say 2 scoots because, again, it's about 100. So it's always 2 scoots because 100 has 2. Right? But right into percent, left out of percent. I'll be writing that a lot to remind us why we're doing this. As a side note, I've never seen a calculator whose percent key works well. Often calculators will have a percent key, but it does different things based on what the word problem is. So don't try and use the percent key on your calculator. It's quicker and more reliable to just use RIPLOP and scoot things and make them decimals than it is to try and figure out how the percent key works on your calculator. Okay, we can go back. Yes.
So when you scoot it to the right, and then you left, it goes.
It goes out of percent. So if I want to go from decimal into percent format, I have to scoot to the right. And if I want to say I'm starting in percent format, and I want to get out of it into decimal format, then I go to the left. Okay, last week we went back and forth between fractions and decimals. We just did between percents and decimals. So what's left? Fractions and percents, yes. Great segue, okay. So I want to write 42% as a fraction. So just like before, I'm going to get rid of that blue percent sign and replace it by something else that also means out of 100 from the secret decoder ring page. Decimal point scoots is a valid option, but it's not the best one because I'm not looking for a decimal this time. So what's the easy way to make this a fraction? Which of the 4 things will we use? Yeah, I'm going to just say this is 42 over 100. And simplify, good point. We're not done because this isn't as fully reduced as it could be. Okay, I can go back if you need. Let's do another one though. So just like before, I'm going to take the 80. If I'm getting rid of that percent, I have to put something back that's equivalent because I can't just change the number. So I'll put it over 100. Everyone good with this? the last slide? Did I leave it too early? Okay. If I have a mixed number with a percent sign after it, my trick doesn't work. Right? I don't want to do 2 3/5 over 100. That just looks kind of awkward and ugly. Maybe I'm starting the wrong way. Maybe I should make this 2 times 5 is 10, plus 3 is 13/5. No, that's not really any better either. So what should I replace my percent symbol if the thing inside the percent is a fraction or a mixed number?
Turn it into a decimal.
No, that would work, but it's the long roundabout route. Which of the 4 things do I want to replace my blue?
So the one that you did was 47 divided by 1 over 100.
Yeah, the last one of the 4 was a times 1 over 100. Yes.
How do you do it?
How to get 13? Let me finish and I'll go back. So I can say one of the things that percent is the same as is a times 1 over 100. I could have done that before and made 80 times 1 over 100, but then I'd have to put 80 over 1 and it would all work out the same, but it would be slower. And we're trying to do the fast one each time. So that was legitimate, but not the efficient way before. But if the thing inside my percent is a fraction, or the mixed number I made into a fraction, then this is the better one. Okay, let me take a quick break, answer to Sean's question. Okay, sorry. So if I have 2 3/5, then I have pi's. So I have 3/5 here, and then I have 2 other pi's. How many fifths are in these?
5/5.
Yeah, they're each 5/5. So altogether, how many fifths do I have? 5 and 5 is 10, and another 3 is 30. The shortcut for that is we take these 2 and multiply, and then add back on the old numerator. See why that shortcut works? Each of the wholes gets the maximum number of, in this case, fifths. And then there's a few extra we have to add back on.
Is that the times on the top or?
Yeah, I wrote things too similarly. Let me actually write it out in words. This is times, because otherwise writing at an angle, you're not going to be able to tell. Okay. Thank you. Okay, let's actually finish this one. So 13 over 500. Is 13 going to have any other factors? No, it's prime, so we're done. Let's look at this again because it's a little funky. We had a mixed number that was actually a percent. We never like mixed numbers. Whenever we see a mixed number, the first thing we're gonna do is this orange and green game, turn it into an improper fraction. So we have an improper fraction with a percent symbol after it. You can picture this on the grid. We're going to shade in 2 boxes and 3/5 of another box out of the 100, right? So it makes sense in a meaningful way. It's just not a friendly thing. We want to get rid of the percent and make it a fraction. So the fast way to do it is to say a percent symbol is the same as times 1 over 100. It's one of the 4 things that percent symbol can be replaced by. And when I do that, then the fraction multiplication, multiply across the top, multiply across the bottom, and we're done. We haven't officially done fraction multiplication yet. We'll spend more time on that later on. But hopefully it looks vaguely familiar just for this one case. Does that help if I... Yeah. Too crowded, better? Okay, don't fret too much about this changing mixed numbers into fractions and mixed numbers in percents into fractions out of percents is not a common thing. So if that's just not something you get, that's okay. Okay, last case. We've gone back and forth fractions to decimals. We've gone back and forth percents to decimals. We've gone percent to fraction. Now we want to do fraction to percent. Maybe we luck out and they gave us one that has 100 in the denominator. And of course, 51 over 100 is 51%. That's what percent means is out of 100. But no, no one's ever going to be that nice to you, give you one with 100 as a denominator already. So the best way to do these is to take the fractions and make them a decimal first and then do RipLop, because RipLop is so fast. Sometimes you can be clever and say, oh, I know this denominator of 1/4. I could change 1/4 into 25 hundredths, top and bottom multiply by 25, and then that's going to be 25%. But by the time you've been clever, someone else is just going to do it the other way. So just like the first thing we did that was a shortcut that wasn't really a shortcut, this is a similar kind of thing. Okay. So 1/4, 1 divided by 4. Then we're going to RipLop. We're going to go right into percent. And we're done. So we're combining the fraction to decimal that we learned last week, top divided by bottom, and then the RipLop we learned a moment ago. Everyone okay with those two? Okay, 1/9 is an annoying one. It's just going to be ones repeating and repeating forever. Yeah, so we're still going to do exactly the same thing, but if it doesn't tell us that we're rounding, we shouldn't. So the ones keep going forever and ever. Questions about any of those? Okay, sorry again about that. Okay, yay. So as it says at the bottom, congratulations, this is a lot. You can now take anything, fraction, decimal, percent, and switch it to any other of those formats and hopefully understand why it's working. A theme of the kind of Math 10 review part of our actual Math 20 class is not only that we're going over stuff you've seen before, but that hopefully we're going a little deeper. It makes more sense to you than it did before. So if this is too slow, I'm sorry, you were good at Math 10, but for a bunch of people here, then it is good to have seen all of this. Okay, lots of good things there. And then we get story time. Okay, any other questions about rounding or fractions or percents before we move on to a new topic?
So I just have a question.
Sure.
So the only homework that's due right now.
Is the rounding one due
Okay.
on Friday. If there's no questions on fractions Wednesday, then a week from Wednesday, fractions will be due.
Okay.
Can you ever go back and redo the format?
Yes, it's
So
just,
if it's not due, you just retake it and submit a new code?
yep,
Okay.
you have to keep submitting codes till you get 8 out of 10 or more. And even after you do, if you wanted to, you could again, but you get the star checked off anyway, so. You know what? Okay. Okay, story time. You can probably put away your notes, but maybe not. Yes. So measurement units are our next topic. And the last kind of changing format is changing the labels of a measurement unit, going from feet to yards or miles or something like that. So that's what we'll do, but we don't have time today to actually do more math. So we're just going to talk about measurement units. A measurement unit is the word that labels it. Like if I'm 63 inches tall, then we say it's inches. By convention, it's plural. Even if something was 1 yard, we'd say the unit is yards, not yards. I'm not sure why English works that way, but it does. Where do we get all our measurement units? Oh, not there yet. Some things have 2 measurement units. We talked about rates last week. So a rate like 30 miles per hour, both the top and bottom of that fraction rate has its own unit. And units can often stack up together in ways we don't care about. So a watt is officially a very complicated thing. We don't care. We're only Math 20, we're not physicists. Okay, if you happen to be a historian and know more about measurement units than I do, please let me know. It's fascinating, but this is everything I know. There's 2 different measurement systems that we'll use in Math 20. One of them is called Standard, American, or Imperial. You'll see all 3 on the internet. I'm just going to call it Standard because that's the one that Math Division uses. The other one should be called SI units, System International, but everyone in America calls it the metric system because we like being rude to other countries. So, we'll talk about both of them. Length. We have inches, feet, and yards in the standard system. Back in the old days, it didn't really care if your miles and things were accurate. That was just land. Everyone would fight over land anyway. What you really wanted was the smaller measurements, so that if you were a carpenter and I was a carpenter, we could work together and our pieces would fit together. So the inches were the ones people cared about the most. And how you got inches is you get a bunch of men in the town together, hold up your thumbs, and take the average width of your thumbs. And that was an inch. And people were the same enough that if you took adult males, then the average of their thumb width was about the same. And then you could do carpentry and I could do carpentry and all our pieces would fit together and the tables wouldn't wobble and the chairs wouldn't fall down. So that's where inches came from. The Roman Empire had 12 inches in a foot. That was pretty much bigger than anyone's foot. But if you put big old-fashioned clunky boots on, you can kind of go heel toe, and pace out feet on the ground because your boots are bigger than your feet. A yard meant more than one thing. It was about a stride length. Some places defined it as 3 feet. Some places defined it as an average waist circumference. Your belt is about a yard. Or people would define it as 2 cubits, so elbow to elbow. This is a cubit, by the way, if you've read Noah's Ark. Right? So this is 2 cubits, this is 1 cubit. So any of those could have been a yard. That's kind of sloppy. So France in 1791 decided to redo the measurement units and actually make them more organized. So they defined a meter as a 10 millionth of the distance from the equator to the North Pole. And since the Earth isn't perfectly round, you have to pick which route you're going up from the equator to the North Pole. And since this is France, they decided the one through Paris. And it was absolutely remarkable. They sent out an expedition to measure that, and they were only off by a 50th of a percent, which for their technology is astounding. So that means, on one hand, they knew they weren't perfect. They could adjust what a meter was and not feel like they're betraying anything. But they don't want to change it too much. Originally, there was a prototype meter. If you were a famous scientist and you wanted to measure things accurately, you would go to a vault in France and they would take out their meter stick and you would try and copy it, and then you'd take it back to your lab, and that's what you would use to measure a meter. They picked iridium because it didn't change too much if it got warm or cold. Then, in 1960, the meter was redefined again. Have you ever seen the physics lab where people take lasers and mirrors and you spin the mirrors and bounce the lasers and things like that? No, it's kind of cool. Bug the science people, maybe they'll show you. Anyway, it became that cheap enough that if you had a laser that you could measure distances using lasers and spinning mirrors in a lab. And lasers were pretty expensive in 1960, but so were plane trips to Paris. So this was better. So they redefined the meter as this many wavelengths of a certain laser, because that was the one most labs had if they had a laser. And that number is funky. Why did they pick such a funky number? Because they're trying to match the meter they already had. And then they discovered a new trick where you could actually measure the speed of light with more bouncing mirrors and lasers, and it didn't even matter what color laser. So now the meter is officially defined as this fraction of how much light travels in a second. And why is this such a funky fraction? Again, they're trying to match the original meter they had. So that's where we get inches and yards and feet and meters. The meter, if you actually have a meter stick, is broken up into 100 centimeters. Because again, cent means 100 for the day. And then if you take a centimeter and break it up, oh, these are all inches. Somewhere I have. No, I don't have a meter stick. Anyway, if I took a centimeter and broke it up into 10 more things, that would be millimeters, because milli means 1,000 like millennium. Okay, we have 5 more minutes, right? Okay, I don't think it'll take that long. Mass is fast. Mass, you had ounces and pounds. Here we're merchants. We're trying to travel somewhere. I have a bag of stuff. I want to sell it to you. You'll want to weigh it. Barley corn is pretty consistent. So an ounce was a pile of barley corn grains, because that was about the same no matter where in Europe I was. It used to be that the Romans had a 12-ounce pound. That was convenient because you could divide it into 4 or 3. But shortly after the Roman Empire ended, everyone changed it to a 16-ounce pound. Because dividing things in 3 equal piles accurately is a pain. Whereas with a scale, I can make things half and make sure they're balanced. And then make it half again for quarters, or half again for 16ths or 8ths. So that was just a better thing for merchants with scales. On the metric system, a gram of water, pure water, is something everyone has in the lab. We don't want to make a tank that's a whole meter on a side. That would weigh a huge amount of water, right? Imagine a big fish tank the side of this length. So instead, we took the little centimeters, and a cubic centimeter full of water was a gram. That was too small for practical things, although good for measuring little bits of water in the lab. So in practical life, we use a kilogram, 1,000 of the grams, which is about 2.2 pounds. Then for volume, volume wasn't used much because people are just terrible at eyeballing volume. If I said, here is a squirt bottle and here is an empty tissue box, if I was to empty this in here, how much would it fill? Is it going to overflow or not? Is it a half? Is it 3/4? Is it 1 1/2? We're just terrible at that kind of thing. So for a lot of history, the words that are about volume today were actually about weight back then. So a gallon was originally how big a sack you needed for 8 pounds a week. But of course, we have modern scales now, so we get the more modern things. 8 ounces of a cup, 2 cups a pint, 2 pints a quart, 4 quarts of a gallon. And I'll start Wednesday by saying, look, here's cute pictures, and you can memorize all of those if you don't do enough baking. That little cubic centimeter full of water that we had as a gram, that was too small to be a convenient size of volume. So they called that the milliliter, and then 1,000 of them would be the liter. So a liter, you know, from liter soda bottles today. A milliliter is more like a sugar cube amount of space. A cubic centimeter and a milliliter are the same thing. I have no idea why LNG shops and motorcycle engines use cc's and everything else in the world uses milliliters, but some artifact of history. Okay, and that's the story time. Don't take off noisily. Let me do attendance because I do have a minute. And thank you for being here.